Let's implement the model interface. It turns out it's possible to build a single implementation of ModelStore thanks to generic types. Our ModelStore will need to keep one immutable copy of a given state type. Whenever a new intent comes in via the process function, we'll apply it to the current model state, creating a new state. We'll broadcast that new state over the ModelState observable. So how do we take intents on one end and turn them into an observable on the other? The process function is where our inputs come in. We'll use RxRelay's publishRelay class to turn this function into an observable stream. A relay is a special kind of observable. You use the accept function to feed items into it. Then we start building on top of it. So we want to use intents to build a new state from an old one. But before we do that, we need to make sure each of these changes will happen on the main thread in an orderly fashion. Once that's done, we add the RxJava scan operator. The scan operator is how we'll take an existing state and build a new one on top of it. If you're now looking at the scan marble diagram for the first time, you should probably be taking a deep breath. It's quite honestly a bit scary, but in reality it's not that hard to use. Scan takes functions as inputs. The idea is that each received function applies to a current state. Sounds familiar? The function then returns a new state. Scan outputs the new state to subscribers downstream and will also keep a copy of it. That copy will be passed to the next function we receive and will repeat the cycle. So intents take in an old state and return a new one. So in our MVI architecture, we'll call this type of function reducers. Let's quickly adjust the signature of intent to match this idea. As you can see, Android Studio is now telling us that store is an observable of type S. In theory, this means we should be able to just hook up our model state function and call it a day, right? Nope. There's still a couple of things missing here. The problem is we want to share an observable. We want our store to be a single source of truth. In RxJava land, these are called connectable observables. So we can turn our plain observable into a connectable observable with the replay operator. Since we want subscribers to get the current state and following updates, we use replay1. And to activate our observable, we use the connect operator on it right away. Don't worry too much if this feels a bit abstract right now, that's normal. As soon as we start executing this code in a debugger, things should start clicking. Speaking of which, we need to do one more thing before we can just do that. We need to build a tasks state model store. We want to store tasks state objects, and our initial task state is empty, has a filter that matches anything, and is idle for now. So I've just created this class and I had it extend model store here with the proper type tasks state. Then @singleton and @inject is toothpick boilerplate to say we want one unique copy of that store for the whole app and that we want it to be available for injection.